Welcome to part one of our Simple Machines notes. So what we're going to be doing is we're going to be going through some notes on Simple Machines. So make sure you have the fill in the blank notes, because that way you only have to write down a few of the words and you can really concentrate on what we're talking about in the video. So this is on machines and Simple Machines more specifically. So a machine is any tool that helps to do work. So when we think of Simple Machines, can you think of any Simple Machines you've used recently? Well, I think of some of the Simple Machines I've used. I've used screwdrivers. I've used a hammer recently. I used a can opener to open up a can. So there's lots of different tools that we've used. Pencil sharpeners are a tool. But there's also some types of tools, some types of machines that you may have used that you didn't really probably even think that they were a tool. Now, machines do not change the amount of work done. And I want to emphasize this. Every once in a while, even I will say, oh yeah, that machine makes work easier, or there's less work to do. That's not entirely true. Machines do not change the amount of work done. Remember, work is force times distance. However, machines, and the ones we're going to talk about as far as simple machines, they kind of make work easier, but they don't. The amount of work is the same. But what happens is we don't have to apply as much force with simple machines. The trade-off, greater distance. And we'll talk more about that later. So the amount of effort saved when using simpler or complex machines is called the mechanical advantage, or the MA. So let's think of a machine that we've used. Say the can opener I talked about. Have you ever tried to open a can without a can opener? Well, it's pretty hard to do, next to impossible to do. But do you ever wonder how a can opener works? Well, it's got something like, well, it's got a wedge in it, and it's got a wheel and axle on it as well. Now, the trade-off is there's a lot of distance that you have to spin. You spin it a lot, the can opener, at least the one I have, you have to spin it a lot further than you would actually have to look at the circumference of the can. So what we call mechanical advantage, or MA. This is the amount of effort saved. So I don't have to use nearly as much force to open a can. It's actually pretty easy. The trade-off is distance. And that effort that I saved, that's called the mechanical advantage. Now the mechanical advantage, again, sometimes we're going to just call it MA. So the MA is the number of times a machine increases an effort force. And the formula for finding that, or the equation, is the mechanical advantage equals the resistance force divided by the effort force. And this is more of a generic equation that you're going to use to find the MA. You're also going to have more specific MAs for each of the simple machines we're going to talk about later. Now, force applied to the machine is called the effort force. And so think about it. The force you apply to a machine is called the effort force. And that makes sense because it's the force that you are applying. It's the effort you're putting into the machine. Now, when you look at the abbreviations behind it, it's FE, and you look at how do they get that? Well, the F stands for force, and the small e stands for effort. So it's the force, and it's the effort force. Now the resistance force, again, you look at you look at the abbreviations. F stands for force, and the little r, that stands for resistance. Now the resistance force, or sometimes this is called the load. So in one of the activities, we're going to have you label the load as L, is the force produced by the machine, and it's applied by the machine on the object. So the effort is what you apply. The resistance, or the load, is the force produced by the machine. So the amount, or the more force applied, the more work the machine will do. So if you apply more force, the more work the machine will do. Again, you got to be careful with this. Force, work equals force times distance. So if you apply more force and the distance stays the same, yes, you are going to produce more work as a result. So we're going to talk about simple machines in this series of videos, and we're going to talk about 6 simple machines. Now, simple machines, these are types of machines that do work with one movement. In general, they do They do work in just one movement. And we're going to talk about 6 types of simple machines. Now, a compound machine is different than a simple machine. A compound machine is made by combining 2 or more simple machines. And some examples of that would be a bike. Can openers that I talked about later it's a machine. It's a tool that I use, but it's actually a compound machine. It's got a wedge and it's got a wheel and axle. When we look at bikes, bikes have a wheel and axle. They got multiple wheel and axles. They have gears, and sometimes gears are put off by themselves as a separate type of simple machines, but yet they're also a wheel and axle as well. We have other types of, well, we got multiple wheel and axles in a bike, and so that's why it's called a compound machine. The can opener has multiple simple machines. It's got a wedge, it's got a wheel and axle, it actually has a lever as well to puncture the can. So again, it's called a compound machine because it has multiple simple machines. A wheelbarrow is another example of a compound machine. When you look at the wheelbarrow, down here you've got your wheel and axle. And then right here, that's where you have, what do you think that is? Well, it actually tells you right here. It's a lever. So it's a compound machine because it has multiple simple machines in it. So here's the pictures of the 6 different simple machines that we're going to be talking about in this series of video. The first one is a lever, and we're going to learn about the different types of levers: a first-class lever, a second-class lever, and a third-class lever. Eventually we're going to talk about pulleys, and we're going to talk about how to find the mechanical advantage of pulleys, as well as find an MA of levers, because we're going to do an activity later on. We're going to have to find the MA of these various activities, or these various types of simple machines. On the bottom there you see a wheel and axle. Again, the wheel is the larger part and the axle is the smaller part. Now, is the wheel always the larger part and the axle is always the smaller part? It depends on what you want the MA to be. Sometimes they're flipped around because you actually want an MA of less than 1. Typically, you want your mechanical advantage to be greater than 1 because it, again, I'm going to say it makes work easier. Again, it doesn't actually decrease the amount of work. It just makes it seem easier or appear to be easier. The trade-off is greater distance. But sometimes you want the MA to be less than 1. Every once in a while with your gear ratios, under certain circumstances, you want it to be less than 1. Inclined plane. This is something we're going to talk about later on as well. And we have inclined planes right here in the school, and we'll see if you can figure out what they are and how you use them on a daily basis. We're going to talk about the screw, and a screw is actually a type of inclined plane that's wrapped around a cylinder. And then we're going to talk about the wedge. And a wedge is actually 2 inclined planes put back to back. We'll talk about that a little bit later as well. So these are the 6 different types of simple machines we're going to talk about in this series of videos, and we're going to practice finding MA of each one of those. Well, this is the end of part 1. Again, if you have any questions about what we talked about, if you want to talk to your teacher some more, we're always there to, you can ask us questions. We'll do the best we can to answer those questions.